Hello everyone. Today we're going to start talking about thermochemistry. The first thing we need to do in order to discuss thermochemistry is go through a few definitions that you're going to need. So first, in the middle of this diagram, you see the word energy. You've likely heard that definition before in middle school and physics and other classes, but it is just the capacity of a system to do work. And there's several different kinds of energy. On the left-hand side, these are ones that you've dealt with endlessly through all of your years of education, but I just want to remind you of them. First, you have kinetic energy. That is the energy an object possesses simply due to its motion. The potential energy, that's the energy an object possesses due to its position in a field. So to relate those two definitions, I put that diagram in the middle. So if you have a really high hill and you have a ball at the top of a hill, if it is not moving, it has a lot of potential energy because one slight nudge to either side is going to change that potential energy. And it actually changes it into kinetic energy. So notice a ball rolling down the hill, it's accelerating down the hill, it's moving very quickly. It has a lot of kinetic energy due to its motion. On the right-hand side are the ones that we're going to be using more often for our class when we're talking about thermochemistry. The first is chemical energy. So this is energy stored in the bonds of a chemical compound. So we can change that amount by either breaking those bonds or forming new bonds. We are changing the amount of chemical energy in that system. Thermal energy, which you'll also see called heat energy, this is the energy possessed within an object or system due to those movement of particles within the system. So if your temperature measured in Kelvin is greater than 0, then it has thermal energy. It doesn't matter if that temperature is extremely low, it can be very, very cold, but those particles are still moving, even just a tiny bit, then it has thermal energy. Notice that when you are forming bonds or breaking bonds, a lot of times that requires you to either put in heat or that thermal energy, or it gives off that heat or thermal energy. So those two are very closely related, which makes sense. We're studying thermochemistry. Thermal energy and chemical energy is likely going to be a very important part. And then one definition I also wanted to remind you of is the law of conservation of energy. So all of these forms of energy, we can't destroy them, we can't create new energy, but we can convert between these different kinds of energy. So we don't just invent energy and we can't get rid of it in a system, but for example, we can change our kinetic energy to potential energy, or we can change our chemical energy into thermal energy, and so on and so forth. So you can convert between those forms. If you need to take a second to pause the video, take any notes that you need to, kind of quiz yourself on these definitions because they will be important moving forward. All right, and then moving on, I wanted to tell you a couple more definitions. I know it's really definition heavy for this time, but we will go into more formulas and equations moving forward. So thermochemistry, we're talking about thermal energy and chemical energy, as you could guess from the name of that. Thermochemistry is the study of heat energy, or that thermal energy, which is associated with chemical reactions and or physical changes. So for example, when you're talking about physical changes, if you want to melt ice to form water, that's going to require an increase in that thermal energy. So you are going to have to add heat to that system in order to break those bonds and melt that ice, to break those hydrogen bonds. So thermochemistry, study of heat energy, which is associated with chemical reactions and or physical changes. Heat is actually the form of energy that is transferred between those systems or objects. And it has to be those systems or objects with different temperatures. So something to remember, if you have something that is hotter than the other object next to it, then that heat is going to flow from the object which is hotter to the object which is cooler. So it's going to raise the temperature of the cooler item. And this is measured in calories or joules, which we'll go into more later. That joules is a capital J. Enthalpy, which we denote with a capital H, is the total heat content of a chemical system. So enthalpy tells us how much heat is in that system that we're trying to address. So usually we'll talk about a change in enthalpy. Either enthalpy is going up, we're increasing the amount of heat in that system, or enthalpy is going down, we're releasing heat from that system. So again, take a moment, write down any definitions you need, quiz yourself, and ask any questions that you need to before you move on.